we're going to start talking about how we can work with different types of functions, whether it's a linear function or quadratic function or higher degree functions. We want to determine their horizontal intercepts by doing the factoring, and we want to use a greatest common factor, GCF, and apply the zero product principle for us to help the process of finding horizontal intercepts by hand. And first of all, just to understand the process, in order to find the horizontal intercept, that means our output value has to be equal to 0, because on the horizontal axis, our y value is equal to 0 on the coordinate plane. So we can say basically the function value is equal to 0 or y is equal to 0. So we can say the function output is equal to 0. And that's going to be the idea we use throughout this entire process. So for part 8, we have a linear function f of x, and if we want to find the horizontal intercept, essentially the x-intercept in this case, because our input is x, then in order to do this, what we want to do is just set f of x to be 0, and in other words, we're setting 8x plus 32 equal to 0. Through this process, we want to look at the greatest common factor between the two terms over here. We had the term being 8x and the other term being 32. So the common factor between these two will be 8, and that's going to be the factor we factor out. And as we factor this out, the first term is left with x, and the second term is left with positive 4. And therefore this is equal to 0. Now by the zero product principle, we say that if we have the product of two factors equal to 0, let's call these two expressions a and b, then we say either a is equal to 0 or b is equal to 0. That's what the zero product principle is all about. And now if we look at the product form, the factored form we have, the first factor we had is 8 over here, and we know 8 cannot be 0, so the only possibility we have left is x plus 4 equal to 0. Therefore, if we subtract 4 on both sides, we would get x is equal to negative 4. And that's going to be the x-coordinate of our horizontal intercept. And therefore, we would say the horizontal intercept is going to be the point negative 4, 0. We need to use an ordered pair because the intercept is a point. And that's how we go through the process finding the horizontal intercepts. And similarly, if we are given a function that's quadratic, like we do in part B, and in this case, we want to again set g of x to be equal to 0. In other words, we have 12x squared plus 42x equal to 0. Now if we want to find the GCF, it might be a little bit trickier because it's not as obvious as we saw earlier. And in this process, we want to think about this in two parts. First, we want to think about what's the greatest common factor between 12 and 42. And sometimes just by looking at large numbers and thinking about the greatest common factor right away, it could be a tricky process. And that's where we can kind of think about what's a more systemic way we can go through and find the GCF. And let's take these two coefficients for example, because they're decently large numbers, and they have a lot of factors involved with these two numbers. So for example, what we want to think about with GCF is we want to first go through the prime factorization between the two numbers, and it might be a little bit easier to see the factors of 12, but nonetheless, let's go through the process just so we're used to the practice of doing this. And what we want to think about is what are the factors of 12, or what times what gives us 12. You might think 2 times 6, 3 times 4, it doesn't matter. As long as these two numbers multiply out to be 12, these are the two numbers we're going to put down. And here I see 3 is already a prime number, so I can't go any further by breaking apart 3 into factors that are not 1 or itself. And then we want to go further, break down 4, which can be 2 and 2. We know 2 is a prime number as well, so at this point we know we're done. We are just working with 3 times 2 times 2, giving us 12. And to put it all together, we can write this as 3 times 2 squared over here. Because we have 2 of the 2's, we can put 2 as a power, meaning we're multiplying 2 by itself twice. And then for the other factor, or for the other coefficient, we have 42. And we can do the same process. We have 42 is equal to 6 times 7. 6 is already 6 can be factored further. 7 is already prime, and 6 can be broken down to 2 times 3. So we have 2 times 3 times 7, like this. And now the nice part about this process is we want to think about how to find the greatest common factor. And the trick here is if we look at the prime factorization between the two numbers, we want to see what are the factors that show up in both factorization and what's the lowest degree that showed up for each factor. And if we look at these two factorization, we notice 3 is in common. And that tells me just through the factorization process, 3 has to be a common factor between 12 and 42. And you can check this too. Through this process, we know 3 times 14 equals 42, and 3 times 4 equals 12, etc. And we also notice that we have a factor of 2 in both, of different power. And then what we want to pick is the lowest degree of that common factor. Here the degree is 1 for 42, and in this case that's the power we want to pick. And that tells me if I want to find the GCF, I'm multiplying all the factors that's in common between the two factorization raised to the lowest degree I have. So it's just 3 times 2, both to the first degree. And that gives me the GCF is 6, and that's a more systemic way to find the factors. It's particularly helpful when you're not familiar with the factors of a particular number, when they're either really big or it's not something that you have done a lot of to kind of memorize all the factors very easily. And once we find out the GCF is 6, that tells me that I can just go ahead and factor out 6 from both terms. Once I do so, I will have 2x squared left from 12 squared. And then for 42x, you can see from the prime factorization, if I take out the 2 and 3, I'm left with 7. And I have 7x over here. But once you do so, you'll notice that I still have something in common between the two terms in the parentheses. And that's where we know that we need to keep going with the factorization. It's not enough. We didn't take out the GCF. And that's really the second part we want to look at. When we have the variable term over here, we want to think about, for the same way, do we have a variable expression that we can take out? And if they have variable terms in variable expressions in common, we want to factor out the lowest degree of the variable. So here, if we look at the two terms, we have x squared and x, and that's in common. So we're again going to factor out the lowest degree of x. So we'd have 6x times 2x now left, because I took out one of the x from the x squared, and then I'm left with another one. And then for 7x, if I take out another x, I'm just left with 7 over here. And that's equal to 0. And therefore we say really altogether 6x is the greatest common factor from the original expression. And through this process, as you get more familiar with, you can do these two steps really in one, just considering we have the variable part to consider and the constant coefficients to consider for GCFs. And as we go through this process, we want to think about the greatest, the zero product principle again, to find out where the intercepts are for our function. And with this in mind, what we can get is either 6x is equal to 0 or 2x plus 7 is equal to 0. Based on this, we can see that if we have 6x equal to 0, x is just equal to 0 by dividing 6 on both sides. Or we can have 2x is equal to negative 7, and therefore x is equal to negative 7 over 2. Therefore, we really have two horizontal intercepts in this case, which hopefully is not too surprising because we have a second degree function, we have a quadratic function, so we can have up to 2 intercepts for horizontal intercept. And therefore our points are 0, 0 and negative 7/2, comma 0. These are the horizontal intercepts we get, and that's how we can list out all the solutions over here. And with this in mind, we can do any type of functions through this process by finding the GCF and apply the zero product principle. So let's take a look at parts C and D now and see what it looks like with a little bit different functions. So in part C, if we want to set the function to be 0, we can just say we have negative 5x squared plus 3x equal to 0. And in this case, when we look at it, just for the constant part, 5 and 3 are both prime, so they don't share any common factor. Now for the variable part, we said we want to take out the lowest degree of the variable we have in common. And in this case, we have x in common. And there is a little bit of flexibility here, but if you don't like to see the leading term, the leading coefficient to be negative, you also have that option to factor out the negative sign along with it. And just to demonstrate this possibility, I'm going to factor out negative sign and x as a GCF. So if we factor out negative x, what we have left in the first term is the negative sign is gone, 5 is still left, and we took out one of the x's and we're left with another one. And careful with the second term, because we factored out a negative sign, that positive 3 becomes negative 3. And you can really check this process by seeing negative x times negative 3 gives you positive 3x along the process. And this is all equal to 0. And now to find the horizontal intercept, we again apply the zero product principle, and we can say that either negative x is equal to 0 or 5x minus 3 is equal to 0. That negative sign in the front is optional because we can quickly see that x can be 0 either way. Or we can have 5x is equal to 0, and therefore x is equal to 3/5 as a result. So we really get the horizontal intercept being 0, 0 and 3/5, comma 0. And these are the intercepts we get. And lastly, let's take a look at part D, where we have this higher degree function altogether. And if we have a higher degree function, the idea is still the same. We want to look for the GCF first. Here, if we want to set 15x cubed minus 75x squared equal to 0, again, this can be your time to practice with a prime factorization between 15 and 75 again. And 15 we can see is just 3 times 5, and 75, if we look at it, there are multiple ways you can factor this. It's 5 times 15. If you notice that, you'll see 15 is a greatest common factor. But let's say if you didn't notice that right away and think this is 3 times 25, and then 25 can be broken apart to be 5 times 5, which gives us 3 times 5 squared. And again, we're looking at the factors in common, and we want to raise it to the lowest degree that they have in common. And we see 3 is in common and 5 to the first degree is in common. Therefore, our GCF is equal to 3 times 5, which is equal to 15. And now that we have done this process, we know 15 is a GCF between the constant coefficients, but we can also pay attention to the variable expressions at the same time. Here, if we look at the variables, we have x cubed in the first term and x squared in the second. The lowest degree of x we have would be x squared, that we can factor out. Once we notice this, we can decide this is a GCF we have. And taking out 15x squared, we're left with x in the first term, and minus, don't forget the sign over here, that 75, if we took out the 3 and 5, we're left with another factor of 5, just based on the 5 squared. So we have 5 left, and that's equal to 0. And using this process, we can see that we have 15x squared is equal to 0, or x minus 5 is equal to 0. And the first part, we can just go ahead and divide 15 on both sides and get x squared is equal to 0. And you might think this is not a linear equation that we have solved, and if you don't see this right away, you can also think about this x squared can be broken apart again to a product of two things. So we really have x times x is equal to 0, and we can apply the zero product principle right away. Alternatively, if you know the square root idea we have, if we want to find some number that multiplied by itself is giving us 0, the only number that we can have will be 0 as a result. So we would just have x is equal to 0. Whichever method you use, you will have that result. Alternatively, we can have x is equal to positive 5 for the other option. And therefore, our horizontal intercepts are set to be 0, 0, and 5, 0 over here. And these would be the solutions for this type of problem. Take a minute to make sure you understand this process and think about how you can find the GCF the easiest way.